Hello. Does your table saw fence slide sweetly like mine does? And does it lock positively like mine does? And is it then absolutely rock solid like mine is? And when it does clamp up, is it absolutely dead square, parallel to the saw blade, all the way along? Right, first time, every time. If the answer to all those questions is yes, move along, nothing to see here, swipe left. Otherwise, stick around. Welcome to Workshop Essentials. I am very fortunate. I've got a top quality table saw. It's an Excalibur. It's a copy of a 1930s Delta design, so quite an old-fashioned design, but it is built like a tank. All cast iron, powerful motor, excellent fence. And the fence always clamps up solidly and parallel to the blade. And it does that because it works on a 3-point system. There are 3 points that clamp across this rectangular front rail. There are 2 pressure pads here and here, which have got adjustment screws behind, and then the cam activates against this pressure pad to give me the 3 points of contact. My first table saw that I had, was not in this league. It was a cheap and nasty thing. And one of the things that was nasty about it was the fence. It had a con rod from front to back, so that when you operated the lever, a hook grabbed to the back of the table and clamped it across like this. The problem was that it was never square. It could be anything between about 88 degrees and 92 degrees. And so for every single cut, I had to check that it was square and tap it into place to make sure that it was square. It was a pain. It was a pain. And the only reason for designing it like that is that it is cheap. It's cheap to make and doesn't work very well. So I made an upgrade for it. And it was exactly the same as this one. It wasn't this one, but it was the same as this one. Before we talk about the fence itself, let's talk a bit about the rail on which it rides. If your table saw has a round rail on the front to which the fence clamps, I suggest that you have no hesitation whatsoever in getting rid of it and use that bar for something else. A square section bar is much easier to work with from a home engineering point of view. There needs to be a gap between this face of the rail and the front of the saw because the fence clamps across these 2 faces. So this part of the saddle needs to be able to fit in that groove. And the easiest way to achieve that is to screw a piece of angle iron to the front of the saw, and those screws must be countersink because they've got to be flush or slightly recessed. They mustn't stick out, not even by a tiny bit, otherwise when this goes left and right it goes bang on the head of the screws. Don't ask me how I know that. The underside of the rail has got tapped holes along it, and they're closer to one edge so that when it's mounted there is a gap between the 2 faces. Now my gap is about 15 millimeters because that's the gap that my original fence requires in order to operate properly. Now this doesn't have to be very heavy weight. This is only about 3 millimeters thick. Everything else, the saddle, the front fence and the front angle iron needs to be very robust stuff. And this angle iron is 6 millimeters thick, 1/4 inch thick. You don't want anything that's not robust. You don't want anything to bend or deform under pressure. It's got to be heavyweight material. And you can get it all from any steel stock holder. And if they balk at selling you very short amounts of stuff, then have a look for a local fabricator, somebody who makes gates and fences and stuff, and see if they will sort you out. But it is quite easy to get hold of. It's all standard sizes, and it's not very expensive either. The fence itself is completely fabricated. There is no welding to be done. It's all bolted together. And the only metalworking skills you need are to be able to saw and file and drill and tap. All the holes in the saddle itself are tapped. So I had somebody write to me recently and said, Steve, I can't make your jigs because I can't tap a hole. And I thought very carefully about how I replied to that. I tried to be encouraging. Tapping a hole is not difficult, nor is it expensive. You do not need to spend a lot of money on a big set of taps to do this job. In fact, I would recommend that you didn't buy a set of taps, because if you buy a full set of a good brand like Starrow's or something, it will set you back a lot of money, because good taps aren't cheap and cheap taps aren't good. It's a much better idea to buy a decent quality tap wrench, which is about $10 or $20. You can pay more if you want, off Amazon, and then just buy the taps that you need. In my collection, I've got M6, M8, and an M10 that I've used once. Now, sometimes the taps come in sets of 3. A taper tap for starting off, a second tap for doing the donkey work, and a finishing tap, a bottom tap, which will get right to the bottom of a blind hole because it's parallel. But all mine are just second taps, and for the kind of what little metal work I do, they work absolutely fine. You do not need to spend a lot of money. The other thing that you'll need is a tin of tapping compound, threading compound, and it's like a grease. One tin will last you the rest of your life if you're a woodworker, and it just makes the job easier and gives you a better finish on the hole. So there are some holes to drill and tap in the saddle. You've got 2 which are for nylon bolts which run along this top surface, and a third one over here which runs along that back rail. So when it's adjusted properly, when you've got it right, it's not running on the tabletop at all. I can get a sheet of paper underneath there just about, and so there is no friction worth speaking of. It's very nice. And they are adjusted. You do need to tap those holes. Even though I've got nuts on the top here, you can't just put a nut and bolt through a plain hole, because you may well need to adjust these to adjust the height to keep this off the table. So that's why there are holes tapped in this as well as a locking nut. On the front face, they're also tapped, and as are the holes in the plastic. And the reason for that is you may need to adjust these out a little bit to fill any extra gap you've got in there. You want as little clearance as possible in this groove, this cavity at the front here, because the bigger that gap, the more clearance there is, the more easy it is for this to rack when you're adjusting it, and it won't slide. So if that is just the thickness of a piece of paper, this should slide very nicely. Thank you very much. For this piece here, I'm using ultra-high molecular weight plastic. It was a piece given to me by my friend Brian. Hello Brian, how are you doing? We must have a chat sometime soon. But if you can't get ultra-high molecular weight plastic, then a kitchen chopping board like this makes an excellent substitute because it slides very nicely. The holes through the main backbone of it, these are all tapped so that I can attach auxiliary fences. I'll show you some auxiliary fences at the end. These are plain holes because they just bolted through into the saddle, and these are plain holes which attach this spacer block, very important spacer block. They attach that. There's embedded nuts in the bottom, there's embedded nuts in the top of this as well for the toggle clamp. So let's take this next door and get it to pieces, and we'll see how it all goes together. I've taken this opportunity to give everything a new coat of paint. If it looks a bit lumpy bumpy, it's because it is. It had textured paint on before, Hammerite, and I couldn't find my tin of Hammerite. It's somewhere here, but I don't know. And anyway, so I've just sprayed it black. That does mean that my tapped holes are now gummed up with a bit of paint. So that is an opportunity as well to show you how easy it is to do some tapping. So I've got my M6 tap. So for M6, you would drill a 5mm hole to start with.
and then you just dip it in the compound. You need a tiny amount like that. I've no idea if that's in the middle, but you don't need very much. And then just keep it upright. Now this is very easy because these are already tapped. I'm only cleaning out the paint. But half a turn and back it off. Half a turn and back it off. And the backing off just breaks the swarf. And say this is very easy, but it's not difficult when you're actually cutting the steel. And it's as easy as that. So don't be put off by the fact that you've got to do a little bit of metal work. And then when you're through, you can just nice and clean. Right, well I've got the rest of the holes to do, so I'll do that and then we'll put this thing together. All right, see you in a bit. I've got all the various components of my fence ready. The backbone, the saddle, the clamp, a couple of spacers. Spacers are important in this, and various nuts and bolts. I'm going to start assembling the saddle. So I've got my slick plate, and although I've got some double-sided tape on it, I don't think that would really hold it. So I'm just going to put that in and try and line it up. You don't have a lot of room for manoeuvre. And then I've got some nylon bolts which will go through and hold it in place. Well, that's not coming off, so that'll slide nicely. Jolly good. And then there's two more to put in. They ride on the top surface of the rail. Now for this particular fence, because it's such low profile, this doesn't really matter. But if it was a much taller fence, you can use these two nylon bolts to make sure that it's perfectly vertical. By pulling one out and screwing one in, you can alter the sort of tilt of the verticality of the fence. And then there's a couple of locking nuts to make sure that they don't go anywhere. So this is going to be the top surface of the saddle, and we do not want these nuts to be sticking up above the surface of the table, because that would just get in the way of our wood. So I've got a spacer. Now I can't remember what that is. I think it's a bit of MDF, but that's just to keep the saddle down below the top of the table so that these do not foul the workpiece. Right, so that's done. The next thing is to fix it to my fence. Okay, so that goes on there like that. And I've got these 4 holes that you can see here. They are tapped, and these in here are clearance holes. So they go through. Let's get this the right way. That is the top. That's the top. So the bolt goes through here on a clearance hole and then gets screwed into this tapped hole below. And there are 4 of those. Now to start with, I'm not worried about getting these properly tight because it'll need squaring up when we're on the saw. But just for now, we'll put it together any old how. And there's also a nylon bolt that needs to go at the far end, because that's going to support the back end so that it doesn't drag along the saw. And I've got a lock nut on that, so that'll be adjusted for height when we get onto the saw. So that's nearly ready. And the last thing to go on is the clamp. Now the clamp needs to be, this needs to be roughly in the middle of the rail. So depending on the geometry of your rail and your particular fence, that will have to be moved up or down accordingly. And so I have got a spacer. Now this is just a piece of plywood, If you could get a piece of steel, that'd be even better. This is the spacer which positions the clamp correctly in the center of the rail. So I've got 4 embedded nuts on the top here so that the clamp can be bolted to it from underneath. And that gives me the right separation there. And then there are another 2 holes here which have got embedded nuts on the underside. And these are so that I can bolt down through the bar of the fence into this block. And now that's fastening into the nuts which are on the underside of that spacer block. And finally, last but not least, the clamp goes on there. Now, I'm no metal worker. I did 1 year of metal work at Cheadle Grammar School with Mr. Aspie, and that is it. So if I can do this, you can do this. It really isn't difficult. And that was 50-something years ago. Goodness me, where does life go, eh? Right, so this is now assembled, and take it back into the machine room and put it on the saw. See you over there. Well, this is the finished fence, and I've slackened off these 2 nylon bolts just a tad to give me virtually 0 racking in there. And I've also had to adjust this, the end of this toggle clamp a bit, because I've put a new rubber pad on there, which is just a very small amount thicker than the one that was on there before. So those have been adjusted properly. And now, as you can see, it slides like a swan on a lake. And it clamps positively like that. You can see now how this geometry interacts with the table. These rider screws here have got to be below the tabletop so that the wood doesn't foul them. So there's a little bit of clearance there, just a few millimetres, that's all you need. And they can also be used to lift this up a little bit. But most of this difference between the top of the table and the top of the saddle is taken up by this spacer here. And it needs to be lifted up just enough for clearance so I can get a piece of paper in the full length there. And that means it doesn't slide on the tabletop at all. And similarly, you can see how this block here keeps the toggle clamp down below the arm of the fence so that the end sits pretty much in the middle of the rail. And I've put a new rubber pad on the end, so I've just had to adjust the extension of this a little tiny bit to give me just the right degree of snugness there. Squaring the fence up is dead easy. Just find something to fill the mitre slot like that, and then hold the fence right up to it. I've slackened these 4 off, and I tighten that, and then just tighten these up. Yep, the dogs have started again. And now, wherever I lock it, that will be dead square. Now, you can use this fence as it is if you wish, but I've usually got some kind of auxiliary fence on my regular fence, and I've also got an auxiliary fence for this. So, for example, when I'm ripping timber, I always use a short fence. This just sits on top of my regular fence and locks into place. And it finishes at top dead centre, so that when the workpiece is finished, the wood can move out of the way without risking contact with the rising teeth and without pressing into the fence, forcing the rest of the wood into the blade. This particular short fence also doubles as a storage unit for spanners and my long arbor and things like that. I've also got this featherboard fence, and although I don't use it very often,
when I do use it, it is just the best. These featherboards keep the wood down onto the table and in towards the fence at the same time because they're cut at an angle. This is great when I need to cut a groove in a cabinet side close to the back edge to take a back panel, or maybe a rebate with my dado set right on the back edge. It keeps the wood down. I know that my groove or my rebate is going to be exactly the same depth all the way along. I'm not have any high spots in it, and it keeps the blade covered because it's got a built-in guard. Don't use it often, but when I do, it's fantastic. When I'm using my homemade fence, I've usually got a fine adjuster rip fence fixed to it. And my fine adjuster rip fence is in two principal parts. There is a base which is fixed, bolted down onto the bar of the fence itself, and then a top carriage which slides over it at an angle. And that's important, it's at an angle of 1 to 10. And if I wanted to work in inches, I would make it at an angle of 1 to 8. So that goes on there like that, and it starts by being set slap bang in the middle. I've got a little ruler here, and I've got a Bristol lever to screw it in place. That's it. And so if I want to make a very precise cut, maybe it matters to the sort of, 1/4 millimetre, I can set it with my ruler to the best of my eyesight, which isn't great, but still. I can set it to as close as I can get, and then do a test cut and measure it. And if it's right, great. But if it's out by, say, 0.3 of a millimetre, I can adjust it by 0.3 of a millimetre because I slacken that off. And because this is on a scale of 1 to 10, if I move it forward 3 millimetres, which I can tell from my scale, that's moved it sideways 0.3 millimetres. And the working face is adjustable, so I can keep that at top dead centre if I want. There we go, like that. This fence works very well for both the table saw and for the bandsaw. So if it's the fence that lets your machine down, why don't you consider building this upgrade? It's easy to make, it's inexpensive, and above all, it is most very excellent. And plans for it are available on my website. If you've got any questions, please leave them in the comments below. I do read every single one, and if I can reply sensibly, then I will do so. Thank you very much for watching. Until the next time, enjoy your workshop. Cheerio!